maybe the single most important fact about climate change is that even if we bring emissions to zero tomorrow, we don't eliminate the problem.
Most people don't understand. We put the CO2 into the system and it will stay there basically forever.
If we want to manage the climate problem that we have at any time, we need to think about tools beyond simply cutting emissions. That's not to say that cutting emissions aren't crucial. They are absolutely necessary, but they're not necessarily sufficient. We might want to do more.
What can we do to improve the lives of humans? It's really critical that we keep developing new tools to confronting climate change, get them on the shelf, and have a set of instructions on how to use them and what the consequences are going to be. If you tell me that there's a new way, let's call it climate systems engineering, that can reduce heat-related mortality, I want to know about that idea. I want that idea interrogated. I want to find out if it's really true, what the downsides are. Climate systems engineering is a suite of tools, and they should be held up to the light of day like everything else.
From its very inception, this university has been built on a few core ideas. Amongst them are that we will commit ourselves always to evidence, to reason, and to rigor. And to my mind, all of those things come together around this topic.
If I were to speak for the students at UChicago, I think a lot of us have the creative thinking and the insane ambition to actually do something about geoengineering, to take this possibility seriously and to study it critically.
Geoengineering has been used to describe two different ideas. One, trying to clean the CO2 out of the atmosphere that we put there, and the other is trying to make some other change that affects the climate of the Earth to compensate for the CO2 that's there.
We never know enough, and there are always surprises. The challenge with having climate surprises is that they can be quite catastrophic. But of course, that does not mean we shouldn't be asking the questions and pushing the boundaries of knowledge. That's the only way we can prepare ourselves for what other surprises may lie ahead.
Of course, from the technical side, we have to understand what's possible and what's not possible, but it's not enough to do that. You also have to take on the legal issues associated and the geopolitical issues associated with it.
This topic demands hard and transparent and open debate. Nobody knows how these technologies should be used, and there are really legitimate views that we shouldn't be ever using them. And my view is it's vital to have that debate in an open way in an academic setting. And UChicago has really been a leader in being able to have open, transparent debates.
We have a profound educational role to play to help foster a generation of students who can really think about the hardest problems with transparency and rigor.
Our job at academia is not to make the decisions, it's to try and provide knowledge about the interrelationships of these complex pieces of the Earth system, about what the risks of these technologies or interventions might be, about what the benefits might be, provide that in an open way that allows individuals to make better decisions.